just as the title implies, we got a lot of content for you today. So I'm Joe Cabral. I'm a product manager for the publishing and execution pieces of the VIA environment, and I'm here with Jim Georges.
That's me, 10 years earlier, without the black eye.
It's actually 10 years for me, too.
Right, it's like, isn't it great? You know, it's a time machine. It's like, you don't even need AI, you just need to have.
I just had to have hair. Yeah. So let's dig into the challenge, right? So, when you look in the overall suite of the data and analytics journey that customers face, especially in the health and life science industry, among other regulated industries, we have great individual products that can accelerate the journey, right? But a lot of times they're distinct. They're distinct point solutions, even if they're under the same umbrella, like SaaS. And so getting those different pieces to talk to each other in a complete and sensible, logical manner is often takes more of an analyst's time than actually doing the critical thinking and the model building and the problem solving that they set out to do. So in a lot of fields, especially HLS, we have SaaS common data models. So if you look at a product like SaaS Health, which Jim is much more familiar than I with.
Well, our real expert,
Jennifer, yes, Jennifer couldn't make it today. But the common data model is basically a defined structure, a defined schema of various tables for input data and output data that will allow you to really clearly and evenly govern what you're doing and what you're doing with it.
So I'm going to play the role of Jennifer Hargrove today, our colleague who is not here today. But what Jennifer's model she's developed is a model to predict medication adherence risk. What is that? You're in the hospital or you get some medication prescriptions. You want to make sure that you're going to take those. If a doctor is going to be following up on someone, you want to make sure their medicines are going to be taken as prescribed. And what this model does is by using a collection of information, and we'll get through some of that in a bit, it identifies the patients that are high risk of being non-adherent, not taking their medicine. It builds a model which produces that prediction tailored to the end user's specific patient population. They can add in other factors that might be outside of their normal data scope, so there's adjustments for what they call social determinant factors. They can identify the top pharmacies and ordering providers to aid in care coordination. So this is like, okay, we need to make sure we focus on these resources because they're the ones that are at highest risk. They include multiple validation checks and bias detections. Are there certain things that our models are predicting that are considered biased? And focus on geographic areas so we can locate resources appropriately. All of these things are in the medication adherence risk solution. That's the goal. That's like the end zone or the end of the rainbow, pot of gold. But we need to get there, don't we?
Exactly. And the problem that so many customers in this industry face is that getting there is the most winding, painful road on the planet. It's like driving in the Greek countryside.
Right.
And all of this, we have three major stop spots. We have our member data, that's what we're collecting in the beginning. We have our prediction model, which is what we're trying to build specifically with the medication risk adherence software. And then we have the full completion of the circle where we bring continuous validation to ensure that our model is continuing to perform well with respect to its changing and drifting population.
I should say, you see that little line that connects those things? Pretend that's a data pipe. Is that a thick pipe? Nope. That's where the friction comes from. Getting that little line built takes a lot of time, takes a lot of effort. And that's where the mapper thing comes in. This is the friction. What we're trying to do
is erase it.
Is a hit.
Frictionless
data together.
We were going to say this
together. Let's do it together. Frictionless data integration process.
That was awesome. Thank you. I'm never going to live that down. So let's go through a little bit of an overview of what the data integration process is. There's many different ways to attack this, but we chose to use the recently added into VIA platform SaaS access to DuckDB. So if you've heard of DuckDB, it's a very lightweight database platform that kind of blurs the lines between database and lakehouse. It can reside in memory and really crunch queries with lightning fast speed, but it doesn't always subscribe to all the same conventions and points of detriment that a lot of databases have, which is about keeping data in one spot and being very isolated and hard to connect to. So we thought this would be an excellent choice because it would give our customers the flexibility to do what they want, where they want it. So we have our customer data that was collected using any number of tools. In the doctor's office, think like tools like Epic, you name them. And that's getting ingested into a SaaS Viya environment. And we're going to ingest it using DuckDB because we can connect to any storage anywhere. We're going to take that and we're going to put that data into S3. We have a nice S3 table bucket. We're doing this because S3's got to be one of the cheapest and most effective storage locations in the world today. Now, S3 originally got a lot of flack because it's just blob storage, just object storage. But they recently added something called table buckets. And those table buckets are for about a 10% increase in cost. So now you're looking at about 0.2 cents per gigabyte. So we're talking very, very minor amount of cost for a relatively normal size of data. You can store data in an actual schema structure. And DuckDB plays very nicely with this. So we pass it on to Jim and his data mapper agent.
So this is what happens. So DuckDB can see that structure. It can send it, give me a send here,
Let's go.
over to data mapper agent. Now we have a SaaS solution, such as the medication adherence risk model, right? It knows what the data structure it needs is. It provides that target schema. So the idea here is to go from this source schema in S3 to this target schema. That's that little tube, that was connecting those things. That's the friction point. What Mapper is doing is going to eliminate that friction by, hit the box, creating mapping code. It's generating, based on the semantic contents of the source and target schema, the link to to the source and the target schema. Press the button.
Yes, sir.
That will then be ingested into the DuckDB database and create a view. And now what? One more time.
Yes, sir.
We get a data structure that is required by the SaaS solution, like the medication adherence. It's as if this S3 bucket is structured exactly like the SaaS solution wants it to be. But it's not replicating the data. It's a view into that data structure. So
go ahead, sorry.
So hit.
So one of the things that we learned when we were building this pipeline was we talked to people about how long is this actually taking. We want to be saving you time. That's the entire point. The end goal is to get your decisions faster. That's what you've been hearing for 3 days, and we're going to hopefully get through this PowerPoint faster so that you can get to your rodeo and have your decisions there.
And this great meal, apparently, yes.
I've been told. And so we heard that this process could take as long as 2 weeks for a lot of times because
Well,
when
2
you're
weeks,
dealing with
but that's being very generous. I mean, it'll take months.
I'm being nice. And because when you're dealing with some of these complex SQL schemas, you're looking at combining tables from so many disparate sources and actually building out the logic on your own and then testing it, repeating, validating, so on and so forth. And Data Mapper iterates through that process repeatedly in seconds. So we're going to have a 4-part demo, and we're going to drive right into that right now. We're going to start with accessing the customer data from putting it in S3. We're going to drive that through Jim's Data Mapper agent. We're going to bring it back and generate those views. And then we're going to pass it to a quick little video showing what it looks like when you actually throw that result data into medication.
That pot of gold at the end of the rainbow. Here, you know what we're going to do? You guys are a special treat. This is done without a safety net. We are doing this live. So here you go. There's no video. So we're going to see it all live. And we'll see what happens. But I don't know what your price is, but there's only 3 people plus Sumitra. Okay, and so you have to just name your price when this screws up. So you'll say, it worked great, okay? I've got some money in my pocket. If it's not enough, I can go to an ATM, okay? Let's go.
Sounds like a plan. Let's dive right in. All right, what you are looking at right now is a hyper-zoomed version of my SaaS Studio. And what I have is a whole load of HLS data that was collected beforehand. And so we have in this data folder about 15 different CSVs with individual characteristics of patients, observations, medical statements, you name it. Some of it's all of various different structures, so you'll have some very easy to read numerical data. There's also some very long form string character data that can be a little bit of a pain in the neck to process and understand. So I have this data, and I'm going to actually use my DuckDB live name. I'm going to create it and connect it using some secrets that I can't show you, so I threw them in a little include statement, which I didn't do in my dry run through and got a little bit blasted for that. We're going to make a
What,
live
you
name.
just gave everybody your
I gave
credentials? How
everyone
nice.
my S3 access key.
Okay,
You know,
well,
they
that's
don't.
free. Another bonus of attending today's
Yeah.
talk, you know.
See, in demo land, they don't teach you that credentials matter until you get in the real world. So we create a live name called ingest, and we can see that right here. There's going to be absolutely nothing in it. It's an empty live name. I lied. There's some things from a previous demo. And it's connected to this iceberg table that we've created. It's a table bucket in S3 containing a whole bunch of pretty much just standard like demo tables, things that you use if you just want to showcase functionality. That's exactly what we're going to do. We're going to use the SAS Access to DuckDB engine to go and pull all the data from the target table. And you know, no surprise, this works exactly the way that you've ever seen ProcSQL work. You're pulling your data, it works fast, it works clean, nothing to complain about, nothing to really write home about either. I'm going to update my libname, and I'm going to actually change it to a specific schema that I've made for this demo called Innovate Medical. And now it's going to be empty. What you'll see on the left is there's nothing inside of this live name. If we check in our S3 bucket, everything is in this main namespace. That's what's correlating to the schema. But what I want to do is I want to look at those 15 data files of raw data, and I want to get them into a nice cloud scalable location. And so I can use DuckDB's language to connect to any kind of data source. You'll notice that in the live name that I defined, I made some specific connections to that S3 bucket. But that does not mean that I'm restricted to only looking at data present there. I can actually read data directly from my disk. So I can use this read CSV function and basically pull data directly from the SAS server on which this is running in this little Innovate Demo code folder. And so now you can see some of the messiness of this data when you're dealing with organizations, websites, URIs, you name it. Much more complex data than your typical friendly little HMEQ lone data set.
HMEQ.
Everyone loves HMEQ. They did it at the keynote, I believe.
I can say that I was there when it was created and helped create it, actually. So this is
I have no comment.
that makes me old. That's all I can say.
So we can go ahead and apply this into, back into the actual use case. We can run this and look at some of our specific tables, but we can do this and create it. And now we've propagated it into the DuckDB live name. So by writing that create table statement, now we have this one HLS adverse event table. If we look back at S3 table bucket, just like you would expect, a little bit of magic, it's exactly what should happen. We have this table here present inside of our S3 bucket. Again, this is an exercise, it's a thought exercise, but it's here to demonstrate the affordability of storing data that can be accessed quickly. You don't have to sacrifice cost just to get speed anymore. I'm going to drop that table because it's annoying me, and I need to actually iterate through everything else.
Is that why you dropped me from your Instagram feed?
Yeah, totally.
I was annoying you.
One of my 4 followers.
Explains me. Okay.
And now I have a macro that we don't need to see the details in, but what it's going to do is it's going to ingest all of these files. It's going to isolate, look for all the CSVs in my little directory, and it's going to upload those into that S3 table bucket. And so we're going to take about 30 seconds where I'll filibuster and pretend that I planned for this little pause as these tables are updating and uploading into the S3 table bucket. Once that's done, I'll prove that it's there, just checking through the S3 table bucket, and I will pass it to Jim, who's going to basically say, I have this data mapper agent. I want it to just connect to this data. So it's in that cloud repository where it's now really accessible. You can get to it from multiple different sources. You don't have to have it passed back and forth between PC, computer, Persona 1, Persona 2. There we go. We've got our 15 tables in this live name, and we are ready to go straight into the SAS data mapper.
Now, what you did, but you didn't show it, is you actually did a ProcSQL on those tables. And I'm going to show you what that ProcSQL looked like when you did it. I'm going to, let's see, switch back to my other, proc contents rather. I said ProcSQL. Proc contents from these tables. That basically, this is all it's there. The proc contents you can see if you're familiar with this functionality. It gives you variable names, data types, lengths, formats, informats, labels. Well, look at those labels. Are those helpful? They're like the same as the variable names. That's not very useful, is it?
It's difficult to extract the context, is the point.
Yes.
And so when you're building that pipe, that friction-full pipe that we described earlier,
right,
it takes a long time to actually, one, ascertain what your data even means. And then, only then can you start building the logic that will connect it.
So what we can do is we can now say, all right, I've got an idea. I am going to take this entity that we've
Left click.
left click. Okay.
Yeah, there you go. It was
Oh, over here.
My laptop bugs sometimes.
Is your lap button backwards? Okay. Come on, you. There we go. I am going to take this proc contents and ingest it into the context window of Mapper. Okay? And I'm going to, so I do that. I say, all right, that's the one I want. Let's open it. I'm going to give Mapper some instructions as soon as it comes back here. Is it going to come back?
It should.
Let's try that one more time. Come on.
If it doesn't, just refresh it, because the only possibility is that the connection may have been severed while I was moving this laptop
I
upstairs.
think the connection was severed,
That's okay. We still have all the future results, so that
All right.
you can pass forward if you need
hopefully. Is it going to reconnect?
it. Better, otherwise we're gonna have a problem.
Well, it's going to get a very short demo indeed. Okay, back to that.
There we go. Perfect.
All right, I think it's perfect. We'll see. We'll see. That no, remember, name your price, guys. So, all right, we take that proc cont. There we go. That's what it's supposed to do. And we're going to feed it into Mapper. And I'm going to type in a command. It says use this file to, let's say, generate a detailed, and I'm going to spell it wrong, schema. I just got to fix that. Schema, SCH, following, and it's this, we're going to give it some context here, the FHIR data specification.
And so what the FHIR data specification is it's a specific model of data structures that a lot of softwares actually output in the industry. Is that, if I'm
That's
not
correct.
mistaken?
Yeah, it's a medical, I mean, you know, Vicki, you want to give us this? No, you didn't, right?
Vicky's taking notes. She's going to rip
I know.
me open
Here we go, yeah.
afterwards.
So basically, it's going down and taking that thing, and it's by looking at the kind of names of the variables and the names of the tables, it's figuring out what these things actually are. And by using the context it's provided that, oh, it's a FHIR data set. Turns out you can actually do that without any extra hubbub. But after it runs, you're going to get something that looks like this. You're going to get a series of table names that were basically what he provided me, but it also is going to come up with semantic descriptions of what all those tables are, because it knows that they're FHIR data. And that's not just for the tables, it's also for the contents of the tables. So each of those tables contains a number of variables or columns, and you can look at all the different columns, and all that information was derived just from that proc contents. The most important elements are going to be the descriptions. Those are descriptions which are going to form the foundation of the mapping process. So I don't know if all these things, I would normally just run from here. I would go to the next button. I'm not sure if that's going to work. But the next step would be to say, all right, let's map it to a target schema. So what's the target schema we're going to use? Well, there's it's this one. I'm going to upload it. And it's not going to work because why?
We have to refresh the page.
And we're going to take
So what that schema is it's basically provided by the common data model location. So when you know what your output data ought to look like, which becomes, of course, the input into the medical risk adherence solution. But you know what that looks like, and you know what your original data looks like. This does all of the legwork to bring those two right next to each other and able to say, here's my data, click, boom, I've got what I need.
Right.
And so, go ahead.
And
Sorry.
so going to the next step, which is map, and I'm going to accelerate this because we have 15 minutes total for this talk. I would go to the map section, which I did earlier, and run. And basically, it will go through, and it will assign each of the source columns to the target columns. You would get to see a little Cylon thing going back and forth, that it's doing the process, and it comes back with this. Now, there's little icons next to each of these tables. Those icons mean, hey, if it's a green check mark, everything's great. If it's a yellow exclamation point, hey, human, take a look and make sure I'm doing it right. So it will then, you open up those tables and you can look and see where the problems actually lie. Some of them are green, some of them need attention. For example, the drug code has an exclamation point. Why is that? Well, it needs to make sure that this is really NDC-11 formatting for the name. So it's going to say, I assumed it is, so that I need to pay attention to make sure that it's if you agree that that's the right format, then we're all set. And you can go to the other fields as well. There's other fields like member ID. I have to do some special work in order to get that information, and you can describe what the special work is. As it turns out, these things will work remarkably well. It really derives this information just from variable names. It's just ridiculous. I mean, and what the next step is to go to the mapping part. Actually, that's the mapping part. What the next part is to generate, basically, the code that is required to do that mapping. And I would click here, generate results, but if I do that, nothing's going to happen because all these things have been disconnected from the server.
I say give it a shot.
I say.
Yeah.
Hey,
no one
likes
refresh. Click refresh. It'll be like 10 seconds.
If you refresh the session, it's going to go back to the start.
Ah, I lied.
So that's going to be a problem. But what would happen is that basically we get three things from this process. We get a plan, which says, here, large language model, AI, behind the scenes, you've gotten the mapping. I told you which variables or variables map together, because sometimes it takes more than one to make a particular mapping. Use that information to make a plan. Now with this plan, it has instructions on how to generate code. What type of code? Well, you have a choice. You can pick the type of code. We need DuckDB code, and that's because he's using DuckDB. And it will have, therefore, generated code from this plan that includes some pretty complicated or sophisticated SQL processing to create the views necessary for the medication adherence risk model. In addition to the code, you're going to also get a summary. And what that summary is, data governance. You have dozens of pages of information about how this code actually operates. You can put it in your data governance file. You can review it to see if it's doing what you expect it to do. And all that information is ready to go. Next, this is about where we hand off to
yes, sir.
Back to Joe here. I would download this information to his machine, and I now have a way of implementing these artifacts.
And so what you've seen is that the SQL Data Mapper software provides not just the compute power and the artificial intelligence to bring you from source to target, but it also gives you a human parsable, human in the loop explanation of why and what it did. And that kind of ties into something that everything you've seen in the last 3 days centers around the idea of human togetherness. We want to basically have this software consider that humans are the end users, and we have to be able to do the responsible thing and be enabled to do such responsible things with
I think the
our
word
data
you're
and
looking
our
for
analytics.
is trust, right?
It is. It's the trustworthy AI booth. And usually in most demos, we would say, go check out our booth afterwards. However, a really funny thing happens immediately after this presentation, which is everyone leaves.
And the Innovation Hub turns into a pumpkin. It's very interesting transformation process. I mean, I've already saw cows down there. It's like maybe it goes to pasture.
Oh, goodness. So what I'm going to do to actually activate all the code that Jim has provided me is I'm going to make a separate DuckDB live name just because I want to keep my source and my target isolated from each other. And what you'll see is it's in the same S3 bucket, but with the database schema catalog notation, I'm able to make sure that everything stays away from each other. And all I've done is I've copied in the code that Jim downloaded. And so we can see some pretty sophisticated stuff, including casts, joins, lots of logic that would take a little bit of time to read and write. But it's all just wrapped in a proc SQL, copy and paste it in, and I can go ahead and run this as it stands. What we're going to see is it's going to pull all the data from the source library that it knows from the proc contents procedure. So it's even contextually environment aware. And it's going to map it into my target library. And we'll see one output data table. Now I'm going to do this for all 4 of these guys, and I'm going to try and squeeze them down so I don't have to drag my cursor too far. But as they're running, we'll show a little bit of a run through of how much SQL is actually being parsed here. You can scroll through that, run that one more time, and then we have a 4th target table. If you remember back in the mapper section, it was shown that in the target schema, we had 4 tables. From the source, we had 15. Now that all this is running, you can see it's running at a relatively fast pace, 2.5 seconds, 0.9 CPU time, because it's leveraging all the capabilities and parallelization capabilities of DuckDB. So we can go ahead and run just 2 proc data sets, just so I can see what's in my ingestation library, what's in my mapped library, and then I'm just going to print the member table as a little sense of proof. Like, hey, did this actually work? And we have data in our target schema. Is the logic valid? All this stuff that we've generated, is it real? Does it actually make data, or is it just slop? And what we can see is we have, here's our ingest library, 15 tables. Here's our output library, we have 4 tables. In this case, Jim spoke that I was using views. I actually chose to do tables just for the sole purpose of I wanted them to be present specifically in the mapper results namespace on S3. If you did them as views, no guarantee that they'll show up there. If you did them as views, however, they would still be completely viable in the VIA ecosystem. And now that we scroll down, we can see our member table in all of its glory. It's only got about 5 columns that we've been able to create out of 15 tables of 50 to 100 columns each. So we've taken a significant amount of data and crunched it into a very nice consumable format, which we can then slide directly to our great friend Jen in the medical risk adherence
And here's
solution.
where Jen would bring us home, and she'd say, look at all these cool things, but we're going to do it with a video. This is virtual Jen. So what she would do is just, all she has to do is drag these prepared tables. They're ready for the solution. She's building her model. She runs the model. She sets up a threshold. That is basically what a cutoff point would be for people who need action on the medication adherence. It runs, and now we have, this model gets embedded in the application, and they can do all kinds of cool reports and analysis, geographics, pharmacies. It's all there. So what we've tried to demonstrate here, I think, in conclusion, I think we're on the conclusion side, right?
Yes, sir. And what we're seeing is Digital Jen is really fast for
Right,
starters.
she's
Rule 1 is she's a much faster mover of the cursor than either of us are live.
Well, it's just because she's just great. What we've seen here is a way of getting something from raw data to functioning output in record time. It doesn't require significant human intervention. It's just basically a frictionless way to get those connections between the member data, the model, and the operational system.
And true to SaaS, it's flexible, just like everything that we've been trying to do over the last few years. We give you the ability to write it in different kinds of SQL flavors. So if you want to use DuckDB, like we did, that's an option. You could use a standard proc SQL flavor if that is your desire. And you can use various different data sources. You know, you can make your lib names that you have your original data for a connection to Snowflake if you so wish. If that's where you're ingesting all of your data for the beginning of your pipeline, you can make your output data and push it into some other source for consumption downstream outside of the medical risk adherence model. And so you have this full complete loop that goes from data ingestion all the way to model building and validation in a smooth, coherent, and frictionless pipeline.
It's a really great innovation. It's a manifestation of the age we live in, where things which are really tedious have become streamlined and frictionless.
Indeed. And that's all we've got.
And that's a wrap.
Take
The
questions.
end. Dun, 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 dun. Oh, wait. Sorry. Yes, Vicky.
One of the friction I always have is the data we receive is wide, but SVM is long.
What's that? I'm sorry, is it different?
Data you receive is wide. What was the second part?
The SVM is long,
Right.
meaning that we have to
To transpose things?
the variable into row.
Right. So you're basically deconstructing the cardinality of it.
Yeah.
Yeah.
Is that something that can be taken care of?
I don't know. I haven't tried it. You want to send me an example? Okay.
Because that is one of the things that we typically have to handle in mapping.
Right.
And that's the question.
This is something, I think that this is possible to do. We've done experiments similar to that. Where it's a complicated, even more complicated thing where if you have a data which is in a key value pair structure, you want to be able to extract and take actions on specific key values and map that to a different key value structure. And it's able to find, we've very successfully been able to map that. This data transpose thing, I don't know what that looks like in SQL, but I think that it's possible to do.
I've seen some stuff using coalesce functions in DuckDB in particular
Yep.
for actually attributing wide data sets and kind of breaking them down into multi-row, multi-record. When you pass that to an agentic solution like the data mapper, there is a dependency on what it's been trained on, of course. And so as this, as this product continues to develop and get updated as we, feed it more use cases, if that capability isn't something that it's already quite good at performing and executing, I would wager that it would come soon with simply just training data packs that we would put into it.
Or skill files, basically, that we
Yeah.
look for. You said you had another question, Vicky.
Well, that is partly answered because we do have something to train it. Because when we have this wide table, when we need to transpose it, then we are adhering to what we call parametric concept. And we do have a very rich set of parametric concepts. Say, oh, these variables map to these
Rows.
to these.
Right,
CD, that's the language.
right.
So the next question is, of course, the training.
Well, a beautiful point about what you've just said is you have that contextual knowledge embedded with you. And so the data mapper agent has that text box conversational window. And so you could tell it, you could say, hey, like, I'm not satisfied with the mapping that's proposed. This should be transposed XY according to XYZ
In fact,
knowledge I have.
you don't have to like type it too. You just throw a file in there and say, this is the structure that you need to do in order to embed it. Yeah.
Ish. That's why I'm looking for something more, but this is
Very cool. Any other questions? You're like moving your hand a little bit. You're like, I'm not sure.
This data mapper, it seems like it runs just on like a prompt contents. You don't actually hand it.
Oh, you can hand it anything else too. I mean, I just wanted to do something harder. I mean, because what you can do is, I mean, there are scraps of information that you can send to the data. So, I mean, if you don't want to use proc contents, I mean, can you just ask for an information map out of a table, of a database, info catalog, I think is the right
In
word.
most Iceberg catalogs, which is what was behind the scenes under this S3 table bucket, you do have the information schema within the Iceberg catalog that does carry a significant amount of metadata that
So
it's generated free with the product of having an Iceberg
So
catalog.
you output that and just capture it to a text file. You could drop that in as context as well.
At the end of the day, though, it does depend on where your data is and how you're
Right.
storing it.
We just really can't upload any of our data, any data at all, to anything that's AI where it could go
Right.
off the top.
Well, the main point is that the data that you're providing to it is the metadata.
Right.
And
That's why it's very cool that you can just do this with just the metadata.
that is, and that, do you know what, I mean, I defined all the principles of Mapper, and principle number 1 was, thou shalt not touch data. And that's it, yeah. And that's it. If somebody puts in a data table, it's going to scrutinize it to see if it's PII and stuff like that. It's protected. I think the original plan of how to manage that, and I think they've implemented it. I'm not sure if the backlog is to say, I certify that this file does not contain protected data.